Hey, good morning. Welcome to another edition of Weather Academy in our dark suit coats here. Okay.
It's kind of like the weather, a little dark
A little
out.
bit, a little dark out there. I'm meteorologist Tom DeVecchio with my cohort meteorologist Craig Flint. Today we do, like in football terms, we called an audible, which means our original plan on talking hurricanes is now being pushed back because of all the wind we are expecting for today. And now the graphics that you're going to see are Tom DeVecchio graphics. They're not the beautiful looking ones that Craig does. They're the ones I find on the internet and say, hey, this looks good. This looks good. Okay, am I breaking any laws? No. Good. All right.
As long as you got the credit, we're good. I'm sure you did fine.
Absolutely. So now we had hoped that by this time that the wind, I mean, we expected the wind to really pick up for now, but we're kind of in a little bit of a lull right now. But the front has passed a little earlier than we thought, and that's this is the current satellite radar. I'll go ahead and put up full screen here. And what we have here is that little trough, that line there, that's a trough of low pressure. And that's about to pass through the area. In fact, it looks like it already passed because we're getting some fog here and some pretty dense fog. But behind it, we will get a lot of wind.
And that's the wind shift that we're talking about. And that's when we think it'll really start to crank up as we head right in through lunchtime, early afternoon.
Yeah, pretty much in the early afternoon. So we are talking wind for today, and you know what causes it.
Yeah.
You know.
It's a big old wind bag. So basically, I got maybe Timmy Hose will sponsor.
Perhaps so.
So basically, what we're talking about think about, remember how we kind of we'll go back to a previous lesson when we were talking about high and low pressure, okay? And adding weight to the air versus taking weight away from the air column. So basically what's happening is we have this powerhouse of a storm that is now situated over Lake Huron. And what's happening is that storm is lowering its air pressure. So it's taking weight off the column. So when a storm lowers its air pressure, it gains in strength. And because the atmosphere likes everything to be in equilibrium. It's trying to compensate for that rapid pressure fall. So basically what happens is, as the air pressure decreases, you have wind rushing in to try and fill that void that's kind of left behind. So think of it like the old analogy of when you take your arm in the bathtub full of water and you go like that, all that water rushes back in behind it. Same kind of concept in the atmosphere. That wind is rushing in to fill that void where the air pressure has dropped. And that kind of is, in part, what creates the wind.
Absolutely. Another one, you know, again, if you go on, YouTube has all those where, you know, where you pull, remember, air is a liquid. So when you pull it out and you get one side of a container with this much water, the other side with this much water, you pull the partition between and it rushes in. Think of a vacuum cleaner, okay? When you turn the vacuum on low, that would be like the low pressure. You know, vacuum cleaner is a low pressure, sucks air up into it, okay? So as the low deepens, what happens? Well, now you're cranking up the vacuum to medium and then high, at least the ones that I grew up with. You had the different kinds there.
Now they're all the robots.
Yeah, right, now now they do the whole thing there. So, so that's what's happening. As Craig mentioned, this one is cranking up, it's on high. So it's bringing in a lot of that air and it's rushing it. And that's all wind is. Wind is moving air.
And the other part of why we're anticipating the wind to be this strong is because of the track of the storm. So we're very close to, that storm actually went just west of us. So anytime you're that close to a storm that's deepening, A, getting stronger, and B, taking a track like this one did, real close to us, that's when it kind of enhances the wind speeds.
Exactly.
So what we look at for wind speed is something called Isobars. It almost escaped my
That's right, Isobars, yes. And that's what you see on this map here. And again,
The yellow lines.
Yes, Tom DeVecchio's, I got off the internet map there. But it's from the Weather Service. We are allowed to use it as long as we won't make money off of it. And Craig and I are not making money off of
No,
it,
we're
so
not.
we're good. The Isobar is simply a line that connects equal pressure. So all those lines on there are lines of equal pressure. The way that we know it's strengthening, basically speaking, the more lines, or in this case, the more circles, and I know it's kind of hard to see, but right just to the right of the middle, that is the low pressure that Craig talked about. And you see those kind of concentric ovals. Those are isobars. If they're packed together, and we call a pressure gradient, which is a change in pressure over a given area. When the lines are close together, like you see there over Illinois, Wisconsin, I hope you know your states, okay? That's where the winds are strong. And you notice to the right, the lines are a little bit farther apart. This is the lull. We're kind of getting the lull in the action now. The airport gusts right now are around 30, but out towards Chicago, they're getting over 50. Taking a little longer than we thought.
Yep.
We anticipated, we're hoping that by now it'd be about 50-mile-an-hour winds and we'd really be able to crank it up while you hear it whistling outside. But as that low moves east and those tight isobars move on by, we do expect the wind to increase.
Yeah, and so again, the closer those yellow lines are together, the faster the wind. And when we talk about energy in the atmosphere, we talk about spin. So if you remember back to our first lesson, or previous lessons, I should say, counterclockwise rotation around low pressure, and this thing's wound up like a top. Now, someone brought up a good point on Facebook the other night. I was doing a little Facebook Live. Is this like a tropical storm? Yes, but not technically, because tropical storms form in the tropics, okay? But tropical storm force winds, yes, they are typical or similar to that.
Absolutely, and they both form in different ways. Tropical storms get their source of energy from the really warm ocean waters, where what we call extratropical storms, storms that form here in the United States, they get their energy from the temperature differences between cold and warm air. And you know, you talked about the energy and the spin up. We have a very, by our standards, very old scale.
This is all Tom. This is all Tom. This shows the difference here.
This is right. We call it the Beaufort Scale. And I should have done my homework a little bit more, but I do know it goes back at least to the 1800s. And it is a scale that uses nature to determine how fast the winds go. Now, we talked about the Fujita scale with tornadoes. That's the extreme. But what we have here, go ahead and pop it up full screen here. This is what we call the Beaufort scale, and it goes from 0 to 12. And it uses nature, trees, flags. Well, flags aren't nature, but you kind of get the picture, okay? Things that are really affected by the wind, and it gives you an idea of how fast the wind is going. Now, generally speaking, the flags, of course, are big. You know, we see them all over the place. Up until the flag is fully extended. You know, when it's, you know, whenever we think of, you know, Old Glory waving in the wind, it's fully extended and flapping. Typically, that is what you call a strong breeze. That's the middle left-hand one, the 19 to 24. And I apologize, the numbers are cut off there. That's a strong breeze. That's when the flag is fully extended. That's when large branches of trees are in motion. You have a big tree and everything's in motion. That's a strong breeze. Everything below that is lighter breezes, and you can see flags go limp. Now notice once you get to Beaufort level 6 in the middle there, notice the tree is starting to bend a little bit.
A little sway.
Yes, the whole tree starts to sway, not just the branches. The flagpole kind of bends. And notice by the time you get to Beaufort 10, okay, now you're getting into, this is actually probably a little bit, now that I'm looking at it, it's a little overdone on the bottom there. 55 to 63 mile an hour winds typically don't blow homes away.
Right.
Okay, so my bad for probably not being a little more disciplined in looking at it. But you get the picture. The Beaufort scale is basically a scale, just like Fujita goes from 0 to 5. The Beaufort scale goes from 0 to 12 to give you an idea of how fast the wind is.
And like you said, ancient.
It is ancient,
Back
yes.
in the day, before we had all the technology and the different building codes, you know, homes might not have been as sturdy.
Exactly.
So
Good
with the
point.
change over the years, you know, it's been adjusted. And now, like, this is just a real quick side note, case in point, for like areas along the ocean. You know, these houses have specific codes that they have to meet to be on the coastline because they are in the path of hurricanes.
Right. They get buffeted all the time there. But this is something good. They're much nicer looking scales. All you got to do is Google it and you'll find all sorts of things with the Beaufort scale. It's a great tool that teachers can use, and it's a visual that everyone understands flags, they understand trees. And they understand wind, so it's a great scale to use.
And you can never outdo an original, so tried and true.
That's right.
You know,
Beaufort
the
scale.
old tricks always work in forecasting.
Absolutely. Now, when it comes to wind and strong winds, of course, we think of land and all the different damage that it can do on land, but we have record high lake levels right now.
Yes.
And imagine if you have a lake that's already near record highs, almost 40-year record highs, and add the winds. You can get some pretty bad flooding.
Yeah, so basically what's happening is you got to think of the lake as a, well, it's a flat surface, but it's what we call frictionless. And what we mean by that is as the wind blows over the water, there's nothing to slow it down. So that wind really gains strength when it's blowing over the open lake water. And once it runs into the land, it encounters friction. Trees, buildings, mountains, stuff like that, which makes it kind of go all wacky. But what the other thing it does is as that wind is blowing over the open water of the lake, what do you think it does to the water? Churns it all up and it pushes it on shore. And that's where we start to become concerned about lakeshore flooding. Now, this is a very localized thing. If you are right on the shoreline, you know what I'm talking about. This wouldn't be a problem for places like Meadville or Warren or you know, Tionesta, anything
basically
like that.
any place south of 90, this would really not be a big problem.
You know, and depending on how strong the wind is, can ultimately determine the magnitude of the flooding along the shoreline. So it really can be problematic. And this kind of also, to a kind of a larger extent, ties into tropical systems and hurricanes, because it's the same idea. That water's just being piled up on the shore. We call that storm surge. And there is actually a particular computer model and computer modeling that the experts use called the slosh model, which it's an acronym for something, but I can't think of it off the top of my head. Basically, that just tries to predict the magnitude of the storm surge. But that's for tropical entities. What we're talking about is just more of a lakeshore thing, and obviously we can't get, you know, tropical storms. And
no, we don't, but we do get, as Craig mentioned, we do get tropical storm winds. And what you're looking here, by the way, this is right from the National Weather Service in Cleveland, which has issued a lakeshore flood watch for Northeast Ohio and a lakeshore flood warning for Erie. Again, Lake Erie, basically a big bathtub. And what happens when you churn it up? Okay, you get the waves in the bathtub. Now you get places like Presque Isle. Those who walk, those who walk on Presque Isle, that some of the sidewalks are washed over.
Oh yeah.
And now if you add, Cindy, can you pop that up again? Because one of the things it says what to expect: strong southwest to west gales. So you can imagine what happens if the winds are out of the south. Well, it's going to push all the water on the Canadian side. But the winds, actually, they just shifted from southwest to west, and we are getting that lull. There's probably a lot of dense fog right now, and you're saying, where's the wind? It's coming, okay? Now you're going to get a westerly wind, so you're going to get that air, the water that's going to, it's going to bounce off the north and come back south, along with the wind that's pushing it in, and it's just not going to be pretty. You can see there waves of 8 to 15 feet. That is humongous. Yeah. Absolutely humongous.
And it's all about angles and geometry.
Yes.
You know, so how the angle of the wind and how it's coming onshore. You know, Tom briefly mentioned that with the southwest wind, it pushes all that water up towards the Canadian side. When it's west and northwest, it piles up here
On the U.S.
along
side.
the
Absolutely.
Lake Erie shorelines.
And this is one of the consequences of, you know, many people, oh, love a mild winter. Yeah, it's great, great. But the lake didn't freeze over. If we had a typical winter, the lake would still have at least some ice, and that would, you know, keep a lot of that flooding from taking place. But without ice to protect the waters, we're going to have, let's just say the flooding this year could be worse than last year. And last year was bad. So we just hope and pray that, you know, we survive and Presque Isle can survive and the lakeshore areas can survive the nastiness. So, so that's a consequence of strong wind. It's not just on land. It definitely affects our waterways, even more so because, you know, oceans are huge and it does take a lot of wind to get them to move. Lake Erie, you know, the second smallest lake after Lake Ontario, they get affected very much. In fact, Lake Erie even more because it's so shallow. The waves can really be much more affected than some of the other deeper Great Lakes. So flooding and erosion are real concern with the wind that we get here.
Yeah, so that's, you know, just one of the many facets that wind brings to a place for our, like a place where we live, you know. So it's definitely a complicating factor, and we are expecting still some strong gusts as we head into the afternoon.
They will. Our best guess right now looks like the noon to 4 time frame will be when we'll get the biggest gusts. But they're going to stay strong through the evening. You know, biggest gusts. That, of course, again, just as an aside before we sign off here, the frictionless or the relatively frictionless lake means that we can get higher gusts here along the lakeshore with that westerly wind. So that's why we've been saying 50 or greater inland, but could hit 60 here in Erie. Now, it won't be all afternoon. It'll probably be in a narrow 1-hour time period. Best guess here, if I had to pick a time, and you reiterated it yesterday, was around 2 p.m. That's, you know, give or take an hour is when we could hit 60. But it'll probably stay above 40 until well past supper hour, and probably above 30 up until midnight before it does finally tail off.
Yep, nothing to slow that wind down out there.
And it will be a chillier wind as well. So bundle up. The 60s are already gone from Erie, and everyone else will be dropping into the 40s by the end of the day.
Come on, April.
So,
do better.
let's get inspired.
All right, inspired. So what inspires you? Again, can be anything in the world. That's what we want to drive home. Yeah, we're talking a lot about weather nerd stuff, but if there's something that interests you as a kid, find out about it, learn about it, Google it. You have all kinds of information at your fingertips, and maybe someday you can get a paycheck for it.
Absolutely, and you're never too young to know what inspires you.
And we're going to keep on going here with the Weather Academy since schools are
Pretty much
officially out
until
the end of the academic year.
Yes.
So if you have topics that we want to discuss, we have a few more in the arsenal that we're going to uncover and explore a little bit. But we want to hear from you, weather at WJETTV.com. Kind of a shift from what we were originally planning today, but prudent because we do have the wind energy today. So hopefully that analysis kind of helped you understand why this is happening. And it's not all that uncommon to get a storm of this magnitude this time of year because we're in that transitional period from winter to spring to summer. So the atmosphere is all out of whack, and remember what I said, it likes to be tidy, but it's never tidy. So we are seeing the atmosphere try to compensate for all these differences right now. So this is not an uncommon thing.
And it will be compensating for a little while based on what we're seeing here.
Yes.
So expect more. Okay, that's our show. Thank you so much, our Weather Academy. Hopefully you've been inspired and hopefully you learned a little something there. We'll be back on Wednesday. The plan is hurricanes.
Yep, we'll talk hurricanes.
Unless something new pops up.
Yeah.
Who knows? So thank you again for joining us. Have yourselves a great day. Stay safe, be prudent, and we'll see you again on Wednesday.
Hang on to your hat and get low.
Take care.